Okay, folks, so we are on the last bit of work that we need to do for this particular project. And I'm not going to have you do correlation tables like I did for these earliest series of videos. What I'm going to have you do is 3 regression models. And so the last one is going to take a little bit different turn than kind of what y'all are doing. It's not hard. And it's something that's just readily doable, but we'll kind of walk you through the process as we go through. So if you are at this point in time, let me go up here and make sure that hold on, let me share my desktop with you. And when I do that, you should see something that looks like this. We will have to the left over here, I'll have my SPSS file version 7. And this version has not only the support score, the count and the support to create my vote score, right, our dependent variable. It's also imported all of this information on the members of Congress. And so we have the first dimension nominate score, the second dimension nominate score, and the party ID calculation that we created, right? We had to find those independents to figure out kind of what Bernie was, et cetera. This is all we need in order to run this particular set of models, and it's going to be pretty simple. So let me walk you through the process. This is the data file. This is our output file. So your output file should look something like this. You should have sort of a party identification model, right? In this one, you get sort of a negative slope for Republicans in terms of support for bipartisan campaign finance reform. This is the first dimension score plot. And this is the second dimension intra-party nominate dimension. And so that one's a little bit different. What we're going to do is we're going to slot in 3 regression models underneath this. And so it's just a matter of running 3 simple commands, and we'll be done. We can print it off and insert these things into our particular table. Okay, so let's do it. Let's go up here and click back on the data file. And we're going to go hit analyze and then go down to regression and then go down to linear, right? And so it just tells it to run a quick linear regression. Our dependent variable is going to be a little bit further down here where we look for, remember, that's the count and that's the support positions. And so that creates the vote score. And the vote score is going to be our dependent variable in this one. For the first model, we're going to use party identification. And so we're going to take this party identification, we're going to move it over to this list of independent variables, and we have basically what we need. It's going to run us a regression between our dependent variable and our independent variable for party identification. There's a bunch of other stuff that you can do in here. We don't need to do it for this particular exercise, so we're just going to run it and let you see what the output looks like. Now, so this one's really simple. It's going to tell you sort of what happens. And so there are some bits of information that we're going to need. We're going to need this adjusted R-square value, this 0.74. We are going to need the number of observations, which is 432 right here in this sort of time frame. And then your coefficients are going to emerge from this table of coefficients down here. The constant value is going to be 87.62. The standard error in parentheses underneath that is going to be 1.30. Right, so these are going to be your first two coefficients for the model. This is got a significance value of less than 0.001, so that is 3 stars, right? If it's 0.01, that's 2 stars, and if it's less than 0.05, that's a single star. Everything else is like no stars, right? And so you'll see how that looks in the other side. Again, party identification, negative 63.66. The standard error term will be found in parentheses underneath that coefficient in the table. And again, this one is significant at the highest level, 0.001. So 3 stars on that one. Okay, that's our first regression model. The next one, we're going to do the exact same thing again. We're going to go up here. We're going to hit analyze regression. Actually, hold on, analyze regression, and go over here and do linear. And this time, instead of party identification, we're going to do the first dimension scores, right? So this is the dominant dimension in DW nominate. It's the one that explains 90% of the variance and members of Congress voting. And so we're going to put that big first dimension in there and see what we get. Okay, run it, click OK. and we're going to get another model specification. So party ID is up here, right? This one is going to be DW nominate first dimension, right? And so same thing here. You're going to have an adjusted R-square value, right? So this one is going to be 0.80, and that's going to go in the model at the bottom. 432 observations is what we tell by the total number of observations in the model. And these are going to be your coefficients, 56.94, and then 0.80 is going to be the standard error that goes in parentheses underneath there. This one is significant, 0.001, and so that is going to be 3 stars, right? Next one is negative 0.78, 0.97. Underneath that coefficient for DW nominate is going to be 1.91, and that one is significant at the highest level, 0.001. So 3 stars on that one as well. All right, and so we're going to enter that into the table that you'll see in just a minute. Okay. Last model specification. Let's go up here and let's run our regression again. And so we're going to go up here, linear. And we're going to go, and instead of removing DW nominate first, we're going to add to it, right? So we're going to go down to the bottom of this list, and there's the first dimension that's already in there. There's the second dimension that's in there, and we're going to run a multiple regression. We're going to put 2 values in here, and so this will be a model with 2 variables. And so we will run it. And that one will go to the bottom down here. And notice you're going to have model summary. It's going to have the second dimension and the first dimension in the same model. Your adjusted R-square is going to be 8.81, right? So that's going to go in the model. Again, 432 observations here. And so that will be in there as well. And then here are your coefficients. So that last model spec is going to have 56.92 for the intersection or the constant value. The first dimension is going to be negative 0.78 or negative 78.31. And the second dimension score is going to be negative 11.57. They will be associated with these standard errors underneath them in the table. And then each one of these is significant at the highest level. So we put 3 asterisks. So let me show you what this looks like whenever we get to the actual, actual table. So let me pull up the instructions for this one. If you look in the instructions, we're going to complete this table, right? And so we can show you where all this information comes from. If we go up to the first variable, right, 87.62, right? That's the constant value. That is in this first value. That's the unstandardized coefficient. And underneath it is 1.30. So that goes underneath there, right? Negative 63.66, that goes here. 1.82 goes there. 432, we get that from the ANOVA, and it just tells you the number of observations that were estimated. And the R-squared adjusted comes from up here, adjusted R-square, which is like right there, 0.74. For the unidimensional model, right, again, that's one right underneath there. It's got the first DW nominate first dimension. We'll put that 56.94 up here in the top for the constant value. 0.80 will be right underneath it, right? The estimated parameter for the dimension is going to be negative 78.97. And so we're going to put that one in there. And the standard error term will be found right underneath it in parentheses. Again, these are significant 0.01. So we'll put 3 stars next to it, right? 3 stars next to that one. And the other ones were significant at that level. So they all get 3 stars. 432 observations comes from over here in the ANOVA table. And then 0.80 is the R-squared adjusted, which is found in the model summary table. Last one, to see where these come from. And this is going to be our multidimensional model, right? So 56.92, that's going to come from that constant value. 0.78 is going to be the standard error in parentheses underneath. Negative 0.78, 0.31, right up there is going to be found right here. And it is going to have 1.86 underneath it in parentheses. The last one, second dimension, is going to have negative 11.57, 11.57, and the standard error term of 2.34, right, in parentheses underneath it. 432 observations found here. and a little bit better on that R squared adjusted, which I'll explain to you a little bit later. So 0.81 in terms of how much the model explains of the dependent variable. So once you get to this point, right, and you have an output that looks something like this, right? You got three models, three figures in here. You've got three model estimates. Go ahead and save this, right? Save this as actually, let me pull this out of the way. It's kind of underneath that thing. We want to save that and make sure that we've got a copy of that. We'll go up here for the micro example. So version 7, this has got nothing updated in it, but we'll go ahead and save it anyway. And so it will be sort of the final thing that we produce. Lucy Lou is barking at the mailman. And so that will be complete at this time. And then the last thing that we need to do for this submission is we're going to go out here, and there's a template that I'm going to provide you. And in that template, oh, that's the macro template. That's not what I want. Let me see if I can find it down here. Here's the template. And so this is going to be the last thing that you turn in for project 3 roll call analysis. So here's your figure 1. What you're going to do is you're going to take this one, delete this figure, and then insert your own, and then update this table for your particular bill, and make sure that you update the notes down here for your bill as well. Then you're going to update this first dimension plot, the inner party. And you're going to delete that one, insert yours in, and update it for your particular issue. And then this is your third plot that you're going to delete, insert your own, and update this table for your particular issue. After this is your table of estimates, and we just walked you through that, right? So you're going to put in the constant values from those estimates. Then you're going to put in the coefficients from each one of those variables. So this one will be the party ID. This one will be the inter-party or the first dimension score, and this will be the first dimension and the second dimension scores. These are the number of observations, and that's that adjusted R square. And so once you're done with all that, and you got all your files cleaned up and ready to roll, you're done, right? Make sure that you got clean files and across the board, and upload all those monsters into the Canvas shell, and we should be in good shape after that. What I'm going to do is I'm going to check your work to make sure that your dependent variables are correct and your independent variables got pulled in here. So I'll replicate it. And then I'll also do a little bit of work. I'm going to do something to sort of estimate the increase in polarity along the lines of what we talked about at the beginning of the semester. And so I'll probably tinker with this a little bit and throw in another independent variable to provide a control for polarization or an explanation of polarization, and we'll test that one. And when we do our discussion of this at the end of the semester, I'll walk you through those results and see if we learned anything about increases in polarity and gerrymandering and things of that nature. But at this point, you're done. You have everything complete, and you're ready to submit it.